One more thing. Are we? Pardon me. I'll be coming back here a lot to ask if you guys can see me, just in case if my service starts acting up. So we know, not necessarily know what we need Python for, but Python is very important when it comes to data engineering. The process of getting data from different sources, Python is very important. The process of transforming the data, Python does the work very well. Loading to databases, Python does the work well. Now, when we begin data engineering, the first project you would do will actually be to make an ETL pipeline in just Python. It will be very easy, so don't need to worry about the difficult, like it's not going to be difficult at all. Just to get data from a source, it could either be reading from a CSV, simple. Transforming it, we could make sure that the date column is actually following one pattern of dates, or if we have any columns you don't need, we just remove it. And then we push it to an SQLite database, SQLite database. Simple. We could do some small insights, but once you build your first ETL pipeline, everything begins to make sense, because that's the first most basic project a data engineer should actually accomplish, your first ETL pipeline in Python. It's a little bit of now. If someone asks you, I know some of you guys are, which one should I do first? Should I do what's the word I'm looking for? Python first, or should I do SQL first? You can learn the both of them, but if you want to place priority on the order, I would say 55% SQL, 45% Python. Now, why would I say this? If you get, most of the companies these days already have a data infrastructure in place. Their database is already there. Data is already in database. The data pipeline is already available, pushing data to the database. So what you need to do as a data engineer is actually know strong SQL, so you could query the data warehouse, understand their data model, understand how to get data for the data analyst, because most times you will be the one the data analyst will come to when they need data. They'll come to and be like, we need data for this or this and this, and then you would query database and you might create a view for this, not a view, full database. Okay, so SQL more than Python, just by small margin, 55% to 45%. Okay, so unless if you get employed in a company where they actually wants to build a data infrastructure from scratch, then yes, you would need more of Python. It just depends on what the standard, this is this, it just depends on what the company needs. So let's begin. Data types and operators. Now, when it comes to Python, there are just 4 data types compared to the other programming languages that have sometimes up to 7 or 8. In Python, there are just 4. And we have integer. This is an integer. 25 as a whole number without a decimal point is an integer. It could be minus 25, still an integer. Positive or negative, as long as it's a whole number, it's an integer. Now, float is another data type in Python. Float is for floating numbers, and it's like numbers with decimal points in it. As long as you have a decimal point in a number, it's a float. After floats, we have strings. Strings are a way of using phrases or words in Python. As long as they are in double quotes or single quotes, they are recognized as strings in Python. And then we have booleans. Booleans is just simply true or false. True or false. They are conditional. These data types are used for conditional statements. So it's just true or false. Okay, you guys are still nice. And then this is a way to print out variable you're declaring. Now there's something I went through in the tutorial. Like I said, the other one is more detailed. If you want to declare a variable, this is the variable and this is the variable, this is the assignment operator, and this is the content it's holding. Age is equal to this. You could declare age as 25 here, and you could use it any other place in your code as age. Okay, unless if you want to change it, then you can change it. But this is how you declare a variable. You could use this is equal to this, height is equal to this, assignment operator is equal to. Okay, let us run this. Okay, so as you can see, this first one is an integer. Type age is an integer. Height is a float because it has decimal points in it. Name is a string, and is student true, Haskell, false. A student is a boolean, is either true or false. That is what we call boolean data types. Now, arithmetic operators. With arithmetic operators in Python, it's very simple. At least the four first ones are the ones we've used repeatedly over and over again. Arithmetic operators, we have addition, subtraction, multiplication is with the asterisk. If you do Control Shift 8, yes, that's your multiplication sign. And they work exactly how they're supposed to work. But there is something that you guys should understand. When it comes to order of operation, I believe that's what we call it, Python follows PEMDAS. I know a lot of us that must have gone through the normal was board mass. Now there are different ways people actually have the hierarchy of important arithmetic operators. But with Python, it starts with parentheses, and then we have exponentiation, and then multiplication, division, addition, subtraction. Any equation with plus and minus and multiplication and division, it's first going to deal with all the multiplication first, and then deals with division, addition, and then subtraction. What I was taught in school was you start with your brackets and then you're off division, multiplication, addition, and subtraction. Python follows this pattern. So if you're into statistics or into data analytics, you should know that if you have a long equation and you want to use Python to solve it, you should know Python it does this before this. It does exponentiation before multiplication, before division, and then subtraction. Okay, now we have this. Okay, so addition number, it adds two numbers together. Subtraction, same. Multiplication, same. Division, divides. Understood. Now for floor division does something different. It's like division, except it only returns the whole number. Now, in this case, we have A equals to 10, B equals to 3. We have A over 10, which is 10 over 3. Now, normally, if you do 10 divided, it will give you 3.33333. But if you do 10 divided 10 floor division 3, it's just going to give you 3. Floor division gives you only the whole number. It doesn't approximate. So even if your answer is 3.99999, it's going to give you just the complete whole number. It doesn't approximate. Floor division doesn't approximate. Understand that. It just returns the whole number. The remainder, we don't consider remainder when it comes to floor division. Now, this is for floor division. And then we have modulus. Now, modulus does the exact opposite. Modulus gives you just the remainder, and the whole number is out. So if you do 10 over 3, it will be 9. Sorry, it will be 3, because 3 divided by 10, it will be 9. Sorry, it will be 3, remainder 1. 3 divided by 10, 3, then 1 is remaining. So what is going to give you is just 1. The 3 is out. Then when it comes to exponentiation is like this. This is how you do exponentiation. And by exponentiation, I mean raised to power. This is 2 raised to power 2. I hope you guys can see this clearly. Let me try and increase this. Okay. Just checking. Can you guys hear and see my screen? Thumbs up if you can hear me and see my screen. Nice. So let's go back. This is simply 2 raised to power 2. Simply 2 raised to power 2. This is 2 raised to power 6, which is 2 times, sorry, 2 raised to power 6 is 2 times 2 times 2 times 2 times 2 times 2. Okay. So now we understand addition, subtraction, multiplication, division. Floor division, which only gives us the whole number of the division. Modulus gives us only the remainder and not the whole number. Exponentiation is raised to power. So let's run this. And there we have it. Addition, it just adds these two numbers. Subtraction, multiplication, exactly that. Division, normal division. First of all, floor gives us the whole number, the answer of the division, but not the remainder. This one, modulus, gives us the remainder, but not the actual whole number out of it. Exponentiation, as you can see, this is 10 raised to power 2. A equals to 10, so 10 raised to power 2 is 100. Now, data structures. We're actually moving fast. I think I oversummarized. But you guys will go through the drive and check out the videos there. I'm doing this since I'm just going to explain basics here so that you guys can ask questions. Because I'm expecting questions. No, first of all, when it comes to data structures, what are data structures? Data structures are just a way of storing several information. There are data structures in Python, there are also data structures in Java, JavaScript, and the rest of that. But with Python, we have just 4 basic data structures. We have lists, tuples, dictionaries, and sets. Let us scroll down. We have lists, dictionaries, set, and tuples. Now, with lists, this is what we used. This is what we use to store information in a list. We use block brackets. Okay, so now with list, you can have different types of any type of data. I know we are only using string here, but you can also have numbers here as well. That as well. You could also you could also have Boolean as well. So understand this. Lists can hold all types of data, and it is mutable. Mutable meaning it can be changed, which means you can actually interact with it, change this to another value, or remove, let's say, this. So it can be changed, and it can hold all types of. We have already talked about that one. It can hold all types of data. It's ordered. It's mutable, which means it's changeable. So this is one way of adding an element to a list. Fruit append. Fruit is the list. Append, this here is what you want to push into the list. So if we do fruit append grape, grape is not going to enter the list, and it's going to be after this true. Append just adds the value you want to append to the last part of the list. Okay. And we could also access an element by index. By index, let me explain to you how index works in this scenario. Now, in Python, let's say we have this like a list with values like this. Now, these values are marked already. As they are here like this, they are marked with index. And index starts with 0, which means this one has an index of 0. This 2 has an index of 1. This 3.142 have an index of 2. Apple 3, banana 4, 5, 6. Understand? Every index in Python starts with a 0. So it's already mapped out here. With index, every single one of this one has a number that they are holding. 1 starts with 0, 2 is 1, 3 plus 5 4 2 is 2, 3, 4, 5, 6, 7. So if I want to do this thing out for you guys to see. So let's say we have this now. The first fruit, I want to print the first fruit, and the first fruit is 1. The index, we're using index 0. Okay. The first fruit is 1. Let's say I want to print the fifth fruit. And the fifth fruit is going to have an index of not fruit, but I added numbers to this scenario. So let's just call it item. So fifth item is going to have an index of 4 because 0, 1, 2, 3, 4. It's the fifth item, but the index is 4. And then the last item. Now, the last item in a list is always -1. Let's say you have a list with up to 100 values, but you cannot start counting it, but you want the last one. So instead of start counting until you now get to the last one, you could just do -1. -1 gets you the last index. -2 gets you second to the last index. -3, you understand the progression. So we have this. So now the fifth item with 1, 2, 3, 4, 5, but the index is 4, which is 0, 1, 2, 3, 4. Understand? So we have done that. Let me give me a moment. Okay. Okay. So if you want to get the number of a list, as in the number of let's call it occupants in a list, you just do length. Okay. Len, then the name of the list in brackets. And in this case, we have 7 items here. So this thing should give us 7 items. And then this one is just Boolean, which is just checking if Apple is in the list. And yes, we have Apple in the list, so it will give us true. So number of items is 7, which is, if we remove this one, let's remove this true. Removing this true is now going to be 6. So length of the item is going to turn to 6. Let us check for something that is not in this list. If you watch the tutorial, you see ANA a lot. There is nothing to it. Now, see, false, because ANA is not in the fruits list. So now that's just the most basic explanation for list. If you go through the Google Drive, you have something much more detailed explanation. So now let's go into dictionaries. Now dictionaries store data differently. List, tuples, dictionaries, and sets, they have their own ways of storing. They have their own rules, rules of storing data. Okay. Let me give you an example now. Let me explain in this case. With dictionaries, what you should understand is value pair, key value pair, key value pair. Okay. So it stored with what is this in curly braces, or is it curly bracket? They call it this. And then this is where the key value come into play. Name is the key, Alice is the value, age is a key, 20 is the value, grade is a key, and these are the values inside of grade. Okay. Key value, key value. Now this is not the only way for you to know that it's a dictionary. This curly bracket, no, because sets also use curly bracket. But curly braces, curly bracket, basically same thing. But with dictionaries, there is key and there is value. There is key and there is value. This could be very long, very, very long. But key, value, that's how you know this is dictionary. When we get to sets, we'll see what set is about. So now, if you want to access a value in dictionaries, this is how you do it. Like I said, they all have their different methods of accessing data or deleting data or working with data. They have their different rules. So if you want to get a value here, let me remove all these unnecessaries. Okay. Now let's say I would like to get the value of the student name and also the student's age. Let us leave grade for now. I would like to get the name of the student and the name and the grade and the age of the student. This is how you do it. You just do student, which is the name of the dictionary, and then block brackets name, which is the key. Once you access the key, the value is also be printed out. So as you can see here, print student name, Alice, age 20. If I want to change this to grades, we should get that. Nice. Okay, now we want to add new values to the student dictionary. I would like to add email. Now look up here, we don't have email. We have just name, age, and grade. We don't have email. But we want to add a new key value, which is email. We want to add alice@example.com to the student dictionary. And this is just for one student too. Remember, the name is Alice, age is 20. These are her grades, and let us add email to the dictionary. Let us remove the unnecessaries. These are just ways to explain the code better, but I think it's just simple to use it the way it is. So that, and that, and let us print student again. So as you can see, we have email inside of it now. Again, this is just basic example of it. So now we go to sets and tuples. We'll stop at here. We'll stop here. Or we could even continue. We'll stop here and ask questions. If you guys understand so far, we'll continue. Okay, so now we have sets and we also have tuples. Now with sets have this obvious rule that you cannot have duplicates in a set. Let's separate this two now. This is set. Now set uses the same curly braces as dictionaries, but can you guys hear me, please? Thumbs up if you can still hear me. Nice. Okay. So sets are different from tuples. Now it's sets, they use the same curly braces as dictionaries, but they don't hold duplicates. No matter how many duplicates you put in a set, once you print it out, duplicates are gone. Okay, and that's one of the good things you use sets for, or that sets are about. They don't hold duplicates at all, but they can hold all types of data. You could even have happen. Okay, so now we have 1, 2, 3, 3, 4, 4, 5. Do this. Now what is going to happen is once I print this, you will not see any duplicates at all. See, so sets immediately removes the duplicates. And let me try something now. I'm going to remove that one from there and put it here and see. Now this is what happens. Sets doesn't just remove duplicates, it also arranges your your data, your values. We have 1, 2 duplicates. It also arranges the data 1, 2, 3, 4, 5, which means it knows that 1 comes first, 2 comes second, third comes before fourth and fifth. So it arranges the data the way it's supposed to be arranged, like numerically. Now there are ways to work with sets, but we will see that in the tutorial on the Google Drive. So let's go into tuples. Now tuples are immutable, and by immutable it means they cannot be changed. And by they cannot be changed, give an example. See how we could easily change or add to add to lists. We could easily remove from lists, we could delete values from lists, change the values in a list, but with tuples we can't do it as freely. Okay, now tuples, with lists you have this, which are block brackets. Okay. Now with dictionaries, you have curly braces. Now with sets, remember what dictionaries, curly braces and key value. Okay. Okay. Now sets. Now we have curly braces and sets. They don't hold duplicates and they arrange your values. Now with tuples, it's immutable, meaning it doesn't just allow you to change values like that. And it is, you store it with normal brackets. Okay, but we don't really use tuples that much. At least from my personal experience, I don't really use tuples that much. I use dictionaries a lot, and I use lists a lot, like a lot. Okay, so now you could do this. I believe they call it tuple unpacking, where you could have something like this, but you could also access it by index. Coordinates of this 10 should be x coordinates is, let me print it so you see. Okay, so coordinates, and this is an f string. Okay, f, and then you have this, and then you have this curly braces here, but this curly braces is for another variable, and the variable that curly braces is holding is coordinates. These coordinates, now we are calling the first value of a coordinate. Remember the indexing part. The first index is 0. So the first index is what was printed out here. Okay. Oh, okay. So now we have comparison and logical operators. Okay. Okay. But before I continue, do you guys have any questions so far? Let's entertain them, please.
Okay, everyone, let's take questions. Well done, Michael. Emmy, do you have questions for
Please give
us?
me your questions.
Kasmir, Hannah, do you have questions? You know, I'm not muted. So waiting be Kasmir.
Okay, well, I don't think anybody's asking any questions. But if you do, just easily call my attention. So let's go into the other part of
This man
sorry.
likes talk too much. Oh, why did I
So
say they should fire her?
comparison and logical operators. Now comparison and logical operators very different from arithmetic operators.
I did not
You
provide
already know
you.
what arithmetic
And it's
operators
not
are, your
my
normal
idea.
plus, minus, multiplication,
Why did
division,
you
flow
just say?
division, modulus, and
Eh?
exponentiation. With comparison and logical operators, or let me show you guys one by one. So first of all, in the comparison operators, we have equal to. The comparison operators are for checking conditions. Okay, like comparison, like comparing values. First one is equal to. This is just simply like, is x equal to 5? If x is equal to 5, then it will come out true. The next one is x not equal to. Equal to. not equal to.
But the laptop with you. Just go
This
there, accuse me, no go no details. Eh?
exclamation means it stop, not equal to. And then we have the less than, and then we have the greater than, and then we have the what's it looking for now is it's how I put it now. One of each. Let's just say one of each before I write this one down. Let me explain this first one. It's like asking, is x equal to y? This one is like asking, is x not equal to y? X is not equal to y. True or false? X is equal to y. True or false? That's what we're asking here. So x is equals to 5, y is equals to 10. Map that first in your head. X is equals to 5, y is equals to 10. So now we're asking, is 5 equal to 10? No, that would be false. Now the second one, 5 not equal to 10. True, because 5 is not equal to 10. Is 5 less than 10? Yes, this one will be true. Is 5 greater than 10? No, this one will be false. Now, this one is, is remember, x is 5 and y is 10. So it's like asking, is 5 less than or equal to 10? There's an or, yeah. Or. Okay,
Okay.
than or equal to. Now, in this case, one of them must be met. It's either it is less than or equal to. If at least it is less than or is equal to, it will be true. When I say this, if it's less than, if 5 is less than 10 and it's true, but it is true. Yes, 5 is less than 10, but 5 is not equal to 10. But as long as we have one being true, it will come out true. As long as you're using or, at least one need to be true, then the answer will be true. This is less than or equal to. 5 is less than 10. Yes, that's true. 5 is equal to 10. No, that's not true. But as long as it will come out true. And then this one we have greater than or, because the or changes everything there. Or equal to. Okay, so we have this x is greater than or equal to y. So we have 5 is greater than 10. No. 5 is equal to 10. Also no. So we have false and false. False and false equals to false. Remember, as long as one is true, it's going to be true. If the two of them are true, it's going to be true. As long as one is true, it's going to be true. But if both of them are false, it's completely false. Let me print it out and show you what I mean. Let's comment that out first and print out this. So, like I said in this part, less than or equal, let us look at it in the printout. So, x, which is 5, is less than or equal to x is 5 and it is less than 10. It's true. But 5 is not equal to 10 and it's false. But as long as 1 is true, that was how we got true. Okay. Now we also have 5 is greater than 10. No, 5 is not greater than 10. That's false. Is 5 equal to 10? That's also false. So we have two false, and that gives us a false. With or, at least one needs to be true for it to be true. So let me just comment, bring this one back. Okay, so now what are we doing? So logical operators, let we just use this true or false value. A is true, B is equals to false. Remember, true or false is for Boolean operators, data types, apologies, Boolean data types. Okay, and we have and, or, and not. is in small letter. And, or, not. Remember these three. Remember when I talked about or like 1 minute ago, when I said for or, one, at least one needs to be right for it to be true. As in, one needs to be true for it to come out true. If we have two values we are comparing, if one is correct, then it's going to actually be correct. But and both of them needs to be correct before it can actually come out true. Like, so we have true and we have false. A, let's just leave it like that. So we have true and we have false. So let me talk about not first. So not basically just reverses the condition. Not A. So A is equals to true. Doing not A turns A to false automatically. Okay. So let's see. We have A and B. A and B, true and false. Understand? And both of them needs to be true for it to be true. If one is false, two of them will be false. Let's check this out and be sure. As you can see, with and, if you are using and for a logical operator, this one are the comparison operators. This one is a logical operator. So the logical operator and two of them needs to actually be true before it can be true. Okay, but with or, at least if one is true, to be true. Now we have A as true, B as false. But just because one is true, then to come out as true. Now remember what I said about not. Not just changes the values immediately to the opposite. It just reverses the Boolean data type. So we have not A. A is true, and once we just use not A, it turns to false automatically. Okay. Okay, now we're going to work with control flow. Now, control flow is where things kind of get interesting, as in very interesting. We'll stop at control flow, we'll stop here. So we have I'm sure you guys must have, in fact, when it comes to programming, if statement is one of the first things that actually makes it stand out, at least for me, when I started learning Python. Once I got to if statement, I was so happy because I could write a long code with just if else, if else, if else. And I would just be happy that I'm getting somewhere. So if statement is just basically telling the computer, if this condition is met, do this. If not, let's check this and let's check another condition. If it happens like this too, do this. Let me give an example now. We have age equals to 18. Now, if age is equal to 18, sorry, not equal to, this is equal to, sorry, greater than or equal to 18. Okay? If age is greater than or equal to 18, then you're an adult. If age is greater than or equal to 13, you're a teenager. Else, you're a child. So on this, okay, you're an adult. Now let's see you are 7. You're a child. Now we could turn this into a program where it has an interface and somebody will just come and you tell the person, impute your age. And the person imputes his age and the person is 34. You're an adult. Yes, we could even change this code to the consent for drinking, age of drinking, which I think is 21 for Nigeria. I'm not sure. So this is basically if the age is greater than or equal to 18, meaning as long as you're 18 or greater than 18, then just print out you're an adult. Elif is just basically else if into 1. Okay, elif is like saying if this one is this, okay, but you cannot use another if under here. If you use another if, you will definitely get an error when you run this thing. So it will be elif, which means it is in the same code. If this is equal to this, do this. If you use if here, this is another completely new code. Okay, so elif, which means it continues from here. So if this is this, do this. If this is met, do this. If this is met, do this. Now let's look at it in a data engineering aspect. I'm not changing this code. So let's say we are expecting data from a certain source, and then this data comes, and then we have a program that checks the number of rows in it in this data. So if this data is I'm going to do this right now. So if we have rows equal to 1,000, let us leave that one there. No. Done. Okay, so let us look at this thing small now. Let's say we are trying to determine whether we should use pandas or PySpark. With pandas, now we all know what pandas is. Pandas is a data transformation tool in Python, but pandas is not meant for handling huge amounts of data. Pandas can handle data from hundreds to 100,000, maybe 200,000 rows efficiently. Now, once the rows starts getting to 1 million, 2 million, 10 million rows, things start getting slow with pandas. So let's just write a code that tells somebody, like another data engineer, that if the number of rows is 10,000, sorry, 1,000, okay, or less than 1,000, use pandas. If it is greater than 1 million, use PySpark. Okay, so if this is greater or equal to 1 million, 123, 123, use Spark. If the rows is greater than or equal to 100, 1, 2, 1, 2, 3, use pandas. Else, this is just covering every other, and the only other condition there is everything below 1,000. So everything above 1,000, above 10,000 has been met. Everything above 1 million has been met. Everything above 100,000 has been met. So the only one that has not, the only condition that has not been met is everything below 100,000. The remaining one for else. So else, so this is 1,000 rows. Is most likely going to tell you use Excel, and then we have a lot of rows. So it's going to tell us to use Spark, and then we have, let's say we have 900,000. That is 900. It's going to tell us to use pandas. Okay, so that's just basic control flow works. I'm going to explain this more into the tutorial. So for now, this is what we have. It has been a pleasure teaching you guys Python. We're going to do this in tomorrow again, and we're going to cover more of control flow, list comprehension, and we're going to go into for and while loops tomorrow as well. I want you guys to understand something. I can teach you everything in Python, but it will not stick. It doesn't until you actually start using it to do something. That is when it stays with you. If not, you will just keep jumping from one tutorial to another tutorial to another tutorial. The best way for you to actually make Python stay with you, in fact, the best way to make anything you learn stay with you is to actually use it to do something meaningful. Okay. Well, thank you guys for having me. Please ask your questions. Somebody. Yes, please, Amy.
I just wanted to ask, is it possible to change the values in a dictionary to set, probably to eliminate duplicates or
Yes, you could use set in a dictionary, but you could only use set in let me give you an example here. Uh, now, I've not done this before, but it is doable here. Now we could use set here. Okay, let's try. I might get an error, but let's still try it. Okay, let's see. It did. So we use set as in the keyword set, not the curly braces set. But the keyword set actually has the attributes of the data structure set. That's what we did here. So we have 85, 90, 92, 92, 92. But it still worked. It still worked. Let me add something that's actually. You see? Yes, 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 it did. I was almost sure it will not work, but thank you. I learned something new today now. You could use set in dictionaries to remove duplicates. But in this case, don't you, you will not use, you need all the grades. So every single grade here should stand for a particular subject. So if you want to use set and somebody scores 85 in mathematics, 85 in English, you now use set and remove one of them. You are causing data to actually miss. So that's very bad. But yes, your question is answered. You could use set in a dictionary.
yes, and to rearrange them. It's in this case, it's coming from the largest to. Is there a particular way for set? Because in the previous example you used, it was going from the,
Front to back.
I mean, the
Yes.
grade. Yeah.
You're asking if there's a way to make it go from lower to upper.
Or it just does anyone
No,
randomly, does
no.
nothing.
In this, using just the sets now, yes, it does. Because as you can see, it's not actually arranging it where we have 190 and then 92. All you're just doing now, you're just removing the duplicates. Okay.
Okay.
More questions. So, Amy, in the next class tomorrow, if you come on time, we can actually talk more about the cloud before the class starts. More questions, please, Anna, the other Anna, Mr. Kashmir. More questions. Okay, well, over to you. Um, our project coordinator at Analog Shifts.
I blew him. All right, thank you so much, Michael. Thank you so much, everyone, for joining in for this class today. I would really love for us to ask more questions. I'm not sure Anna is here. I want to hear from everybody. Um, let's do a quick evaluation. Michael, I don't know if you have questions like a set of knowledge check, and let's run through questions. Everyone should ask a question. I want to be sure that everyone really understood what was taught today, and before we move forward. And like you said, yes, Python doesn't speak by learning it like this, it's by making use of it. So, I want us to pick our brains a bit. Michael, do you have something like that for us?
Okay, so you want to ask questions, just like knowledge check questions.
Yes, please. Kasmiri,
Yes, yes,
Hannah,
yes.
Amy, I hope you're here.
I'm here. I have a background noise. That's why I've been quiet. But I'm
Oh,
here.
oh,
Thank
it's
you, though.
fine. It's fine. All right, Michael, we're ready for the knowledge check. Hope everyone is ready. Drum rolls. All right, let's start with
Okay, let's see. Let's see.
Michael.
Okay, I'm just going to make this very easy. In data types in Python, which data type holds decimals? So we have arithmetic operators in Python. But remember, I told you about the order of precedence, which is the hierarchy of what's the word I'm looking for now? As in which one it takes more importance. Now, I mentioned two. I mentioned which one does Python use when it comes to the order of precedence with arithmetic? Very close, very close. Anna, very close, but the N is M. But yes, you're right. We
Okay.
have PEMDAS, parenthesis is exponentiation, multiplication, division, additional, subtraction. The actual whole number. Okay. Yes, modulus gives you the remainder, the floor division gives you the actual whole number. Now answer this one, true or false. If I have, yes, correct, Mr. Casimir, an integer can hold negative and positive values. Now, let me ask you this one. If I have a string and the string is, let's say, name equal to Anna, and we have something like, we have something like this. No, no, let's not do that. But I'm still going to ask this one now. If you multiply a string by a number, like if you do Anna times 5, what's going to give you? What's it going to give you? I did not teach this one, but I would like to see if anybody has. No, it's not going to give you an error. Okay, so now I have sets and also have tuples. Now,
What's the question? Sorry.
the question is if you do wait, let me show you what I mean. I want to share my screen again.
What's the question? Sorry.
So I said if we have like Anna times 5. Now the question is, what is it going to give you as an answer if I run print? Somebody said error, but it's not going to give an error.
It will be the string Anna times 5.
Anna, something like that.
Yes, it's going to
Oh,
give you Anna.
okay.
Well, let's see.
Yeah.
And let's give you small space for you guys to see it. Yes, 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 and yes. But if we do this, this is where we get an error. Now you can multiply string by a number. Let me just run through the rules. You can multiply a string by a number, which is what we did here, and it gave us the same string over and over again times the number. But if we add it, it will not work because you're trying to add a string and an integer. It will not work. But if you want to add an integer to an integer, it will work. If you want to add float to an integer, it will work. If you want to add string to string, it will work. Okay. But if you want to plus to add string to string, as long as you put double quotes, even the number is now a string. Okay. So what else? Yes, that was a question. So which other question? Let me see. Okay, so let me ask the data structures question now. We have lists, tuples, dictionaries, and sets. Now we already know that list can hold all types of data, whether it's string, whether it's tuple, sorry, whether it's string, integers, floats, or integer floats, or one more, Boolean values, yes. So in dictionaries, what is the key difference about a dictionary? Anybody? Key value pair. Yes, key value. That's what makes a dictionary unique compared to the other ones. Good. So now let's talk about set. What makes set unique compared to the other ones?
To order items.
Yes, it orders the items. But one more. Yes, Amy has already said it. But yes, you are right, Anna. It orders the items and it doesn't take duplicates. No matter how many duplicates you put into it, it doesn't take duplicates. Now, we have which of these data types is not immutable, which means which of the data types is mutable. If it's mutably changeable. So yes, which of them is immutable? We have lists, we have dictionaries. So between lists, dictionaries, and tuples, which of these? Yeah, you're not even letting me finish. God. But yes, you're right. Tuple is not changeable. Okay, so let's go back and see which other questions we could ask you. Okay, now can somebody tell me the major difference between and or? You might have to speak now.
The operator difference.
The logical operator, yes, and or.
And is to combine both, like everything, whatever you mentioned, or is either to checking like one of the item.
Yes,
And
that's yes, that kind of explains it. With and, both of them needs to actually be true before you can actually get through. But with or, at least one needs to be true before you can get through. So yes, that's the major difference. So another person, what does not do? The not operator. What does it do to a Boolean data type?
I guess it will exclude.
No, not the right word. Exclude.
If it's for you to
Cancel
log
out
in,
the
I don't have. Well, it's for you to watch.
the statement. How do I even put it?
Can you see my phone there?
But the word is not cancel out.
uh,
If you use a right word, I would, or if you just explain it plainly the way it does, and it makes sense, then I'll agree. Anybody? What does not do to a Boolean value?
Oh, that shit, Gary.
all right. In Boolean, if we have maybe
I just buy new code.
a statement that says a is equal to one, and then you put it, you want to print it and say that a not equal to, you put it in, you say a not, if you say a not equal to one, when, as soon as you put not, it will actually uh, turn the operator, it reverses the statement. I don't know.
The reverse is the right word to use, but when you are trying to explain it, it was starting to overcomplicate it. But yes, if you have A equal to true, and then you have a statement not A, and that just means not true. Not true is false. So yes, it reverses the Boolean value from true to false and from false to true. That's what not does to a Boolean value. Let me go to this again and see which other question is there. Okay. Now, somebody tell me all the comparison operators. There are six. And you could even come together and list out the ones you know. Everybody can come together and say it.
Comparison. Oh, God.
I'll give you one comparison operator, then you say the rest.
We have a lot of them. We have equal, not
Okay.
equal,
Okay.
uh, not, or greater
No,
than,
that's the logical operator. Okay, yes.
uh, greater than, less than,
Mm-hmm. That's four.
greater greater than
Greater than
equal
or
to, less
equals
than
to.
equal to.
Less than or equals to.
Yes. So we have equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Yes, you guys are correct. Let me see which other thing I can use. Let me not go too deep. I wish you guys have gone through um the Google Drive. Then everything will be a lot deeper. The questions will be a lot more difficult. But so far so good. You guys we are following the class. That's what I'm happy about. So thank you.
Awesome. Was Thank you so much, Michael. Was an awesome session. Everybody did really well. Well done, Anna. Well done, Amy. Well done, Casimir. I also learned too. So please, I would like everybody to go through the link I sent of the pre-recorded classes. So the classes are short. I don't know if anybody has gone through it. They're very short, 1 minute, and you just get the major info you need. And so that for the next session tomorrow, we can have hands-on practice. I think Michael need to download Anaconda and one other thing. So please,
No, just
let's
Anaconda.
just
Just Anaconda.
Anaconda. Okay. So let's
Yes.
let's go through the tutorials, and they're very short. I promise, they're really short, and they are very
Okay.
easy. So let's go through it, and then ahead of tomorrow, so we meet tomorrow at the same time, and it's going to be the same meeting link by, so that is 6 p.m. um West African time and 11 a.m. Central time. I also, when from the form, I realized that we have other time zones, but I think we'll just have to stick with Central time for now. Thank you so much, everyone, for joining in today. So see you in the next class. If you have anything to say, anybody. Okay, I mean, let's have you.
Yeah. Is there a curriculum for tomorrow? Like what are we looking into tomorrow?
Okay, so can you send me a text? I would send the curriculum specifically to you. I sent the curriculum to everyone that has responded to the Google form, and
I have
uh, you
you
have.
did send to me. You
Huh?
yeah, you did send to me.
Oh, I'm so sorry,
I'm
please.
just asking specifically for tomorrow.
Okay, so
You actually did send the curriculum to me. That's
I sent the curriculum to you already.
yes, you did.
Okay.
Oh,
Yeah.
Yeah,
I don't
so
think I
if
re-
we're following the curriculum, if we're
I
following,
don't
that's
think
the general curriculum. So for tomorrow should still be our hands-on hands-on challenge. That should be what we'll do tomorrow, right, Michael?
Yeah, we can still do hands-on challenges. But remember, the assignments are there also. If you have the time, attempt the assignments.
You've heard it from Michael. So thank you so much, everyone. That is basically it for tonight. See you tomorrow. Thank you,
Yes,
Cassius.
Mr. Casimir. Okay.
yeah, I don't think I received the curriculum. Hello?
Now, I can't
Hello?
hear you. It's a bit faint.
Hello? I said
He said,
I don't think I've received the curriculum.
Mm,
Can you hear me?
yes, for me, please let me check.
So do you send it via email or
No. Okay, actually, I haven't sent it to you. I'm so sorry about that. I'll send it right now.
all right? Okay. Thank you so much.
Thank you. All right, so that's all for today. Thank you, everybody. I can go now. See you tomorrow.
Thank you.
Bye. Eh? I'm not sure because I don't have my own data. Eh? I said I don't have my own data. It's work data I have.